Myself, Dr. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study some of the definitions, basic terminologies in engineering mechanics. Let us begin with what is the definition of engineering mechanics, what are the types of mechanics. So, engineering mechanics is basically it is the study of the branch of the science which describes and predicts the conditions of rest or motion of bodies under the action of forces. So here, what is the meaning of describes and predicts the conditions of rest or motion? We can know the rest and the bodies are in motion. That means, suppose here I am sitting at rest on the chair. The person who is sitting, that is a rest. And when the person is traveling in a vehicle, or the vehicle is with some revolutions per minute, some speed, the vehicle is moving, that is in under motion. So it represents or it predicts. What is that which describes the science which describes and predicts the conditions? What are the conditions of rest and conditions of bodies? So here the mechanics deals with the conditions of rest or motion. Means when the bodies are in rest, condition means what is the resultant force it is being acted, what are the reaction forces are being acted because of the weight or the load is being acted on the body. So what is the resultant force is the outcome. So here those are the conditions of the when the bodies are at rest. When the bodies are in motion, we are going to find out at various velocities, accelerations, because of the application of the force, and under certain motion. So we are going to find out here these are the conditions of rest or in motion of the bodies. So here there are various three types of mechanics. Number one, the mechanics of bodies, mechanics of rigid bodies. Number two, mechanics of deformable bodies. And finally, the third one is mechanics of fluids. That is nothing but fluid mechanics. So these are the broad category or classification of mechanics. Number one, once again, mechanics of rigid bodies. And number two, mechanics of deformable bodies. And finally, the mechanics of fluids. These are the various categories or various classifications of mechanics. But what we are going to study in engineering mechanics and in strength of materials, we are going to study the mechanics of here in engineering mechanics. We are going to study the mechanics of rigid bodies, and also in strength of materials, we assume that the body is a rigid body. What is the meaning of rigid body? Here we are going to study in coming slides. Now here the bodies are perfectly assumed to be perfectly rigid. That means when the load is applied on the body, the distance between the displacement between the 2 points is negligible. That means no deformation. That body is known as a rigid body. So the mechanics of rigid bodies is again divided into two parts. Number one, statics, and number two, dynamics. The statics deals with the bodies at rest. When the bodies are at rest, that is only dealing resting. That means ideal conditions. That means the body is at rest. That study of again the conditions of rest. The conditions of rest when the bodies are at that is the statics deals with the bodies are in rest. What is dynamics? The dynamics deals with the bodies when they are in motion. So these are the dynamics and statics. So what are the topic comes under statics, and what are the modules comes under dynamics? The statics comes under the topics comes under the statics is coplanar concurrent forces. And the module of next one is the friction. The module of friction comes under statics. So, and also stresses, study of the stresses. So these are all topics comes under the bodies at rest or statics. And one more topic, some more topics are here: the centroid and center of gravity. And third one is moment of inertia. Moment of inertia. That is area moment of inertia, and number one is mass moment of inertia. So these are the topics comes under the category of statics part of engineering mechanics. The mechanics deals with the mechanics of rigid bodies. And here the dynamics with the bodies in motion, when the bodies are in motion, the dynamics deals with here, that is kinetics. And next one is kinematics. And next one is work energy equation. Work energy equation. So these are the parts comes under the category of dynamics. All right. Next, some of the terminologies. What are the terminologies we are going to study here? What is the space? And what is the mass? What is the scalar quantity? What is the vector quantity? What is the vector? What is the scalar? And what is parallelogram law of forces? Polygon law of forces? Transmissibility of forces? These are the certain basic terminologies we are going to study now. What is the space? Now, the first one is the space. Generally, space means we think that it is the sky zone. Okay, the space, that is the only space. Beyond the sky, there is the satellites playing, that is the space. But the meaning, exactly the definition of the space means is the geometric region occupied by the bodies whose positions are described by linear. How can we describe that position? By linear and angular measurements from with reference to coordinate system. So there are different types of coordinate systems: Cartesian coordinate system and also polar coordinate system. Now here the linear and angular measurement, we are going to identify the position of your body. What is the space here? Is the geometric region occupied by the bodies whose positions, how can we, it is occupied, the body is occupied geometric position, geometric region. But how can we measure it? That can be described by using the linear and angular measurements relative to, what is the reference to, coordinate system. So for two-dimensional, suppose for three-dimensional bodies, if we are going to solve the three-dimensional problems, we are going to use three independent coordinates are going to be used. Now for two-dimensional problems, that is the plane problems, how many coordinate system? Two coordinates, only two coordinates are required. So this is very important. For three-dimensional problems, x, y, z are coordinates are required. Three coordinates are required, three independent. That means x-axis, axis x, axis y, and axis z. We are going to consider for solving the three-dimensional problems, x, y, z. For two-dimensional problems, we are going to consider any two axes, either x or y, or x or z, or y or z. Two-dimensional, two coordinates are required. That's why we are going to use axis, coordinate x and coordinate y. So here, any point, if you want to make it, that is x comma y. But the distance here, this is x comma y. That is means two-dimensional problem. There are two coordinates are required. Alright. For three-dimensional problem, again, how many coordinates are required? Three independent coordinates are required. Now, what is the next very important definition, very important term is the time. Time is so important. What is the time? Everything in the nature is the function of the time. Due to function of the time, birth takes place, and also due to function of the time, death takes place. Due to the function of the time, growing takes place. Due to function of the time, dwindling takes place. Everything is made of function of time. So that's why in nature, the system is the function of the time. That's why the function of the time, that system is known as the dynamic system. So time, what is the time? Time is the measure of what? The succession of events. So and it is the basic quantity in case of dynamics. So if this time, always the function of the time comes in the dynamics. Again, the dynamics, also structural dynamics. Structural dynamics means the study of the vibrations. So the vibrations related to the function of the time. So amplitude versus displacement, amplitude versus the time, x versus t. If you are going to draw the diagram, x amplitude and time t, x and t. So everything is the function of the time. That's why here this is very important terminology in this case of studying the dynamics. In case of engineering mechanics, the part of dynamics, the time is so important. So the equations such as S equal to ut plus of at square, v square minus u square equal to 2as, v equal to u plus at, and the t means what? Time. So time is the measure of the succession of events. That's why it is very important for, it is a basic quantity in the subject of, in the part of the dynamics. So next, what is the mass? Mass is the very, very important terminology in studying engineering mechanics. Here the mass is a measure of the inertia of your body. The mass is the measure of the inertia of the body, and also mass is the matter. So mass of your body here is the mass can also be thought of the quantity of a matter in the body. And here, if we consider W, weight, W equal to mass times G, W equal to mg, force, F equal to mass times acceleration. So, and you can see so many problems related to the mass. Alright, omega n, that equal to under root of k by m is the mass, is the stiffness. Okay, here there are different terminologies, different definitions or descriptions about the mass. One of the description is that the mass is a measure of the inertia of your body. What is the inertia? Means resistance to change of the velocity. It is resistance to change of the velocity. Every body having certain mass. That means a matter. It is made of a matter. Our human body is made of a matter. But when it is made of a matter, that means it's the mass. The mass is the measure of the inertia of our body, and also the quantity of matter in your body. It is the quantity of the matter in your body. Suppose the person weight is W, some 70 kilonewtons or 60 kgs. Okay. The point is that W equal to mass times gravity, acceleration due to gravity. This m is the quantity of a matter of your body, and this m also acts as a mass moment of inertia. In the case of mass moment of inertia, I equal to mk square. This m, where k is the radius of gyration and m is the mass of your body. The mass is represents the measure of inertia of your body. Okay, next one. And also this mass affects when the satellite is going against the acceleration due to gravity. That's that when the velocity with which the space shuttle is moves, the satellite moves in the sky, that is called escape velocity. So the mass of your body, that mass affects what? Gravitational attraction force between it and other bodies. Okay, so that's why this mass is so important. The mass is the gravitational force. Suppose the weight is proportional to the mass. If the weight is high, that means mass is high. But why? Because the gravitational acceleration due to gravity, G remains constant. So this W equal to mass times acceleration due to gravity, m times G. And this force, what type of force? The gravitational force is very, very important in studying what? The part of statistics, that's the part of mechanics of rigid bodies. Gravitational force. Now, suppose if the body is acting, the body is in place. This is having a m. M into Z acts downwards. This m into mass times gravitational force, that is called weight. That weight acts vertically downwards. Alright. So here we have studied the terminology. What is the importance of the term? That is the mass is the term. How much it is important we have studied here. The next term is particle. Here the particle, we consider it. What is the importance of particle? We are going to study here. Now let us define that a particle is a body of, very important, negligible dimensions. Okay, the particle is a body of negligible dimensions, and also in mathematical sense, a particle is a body whose dimensions are considered to be near to zero. The dimensions of a particle, the dimension of a particle is zero. What is the dimension? What is the geometry? What is the size of a particle? It is zero. So that what we consider here, so that we may analyze it, and as a mass concentrated at a point, a particle of your body is what? Negligible dimensions, and also in mathematical sense, it is a negligible what? One more, the geometry, the dimension of a particle is zero. That's why for engineering mechanics analysis, we consider a mass, whole masses passing through, concentrated at a point. Alright. So that point we consider as centroid or center of gravity of that body. Now one more thing is that here we choose a particle as a different element of your body in studying while doing analysis in engineering mechanics. And also we may treat this body as, sometimes we consider body as a particle when its dimensions are irrelevant to the description of its position or the action of forces applied to it. So here, while doing analysis, while studying static analysis, what we consider, this concept we are going to use it. We consider a particle, that means what? The whole mass is passing through a point. That point is having, what is the characteristic of a point? The point is having zero dimension. Alright. And also, yes, zero dimension, nothing but negligible dimension. Negligible dimension, so that we use that point through which the whole mass of the body passing through it. Alright. That's what while doing. This is the mass, whole mass, which is passing through where? Through one point. That point is the centroid or center of gravity. The weight, what is the mass? Mass, what is the weight? They are having certain mass. What is the weight here? M times gravity, gravitational G, which is vertically acting downwards. Alright. Next, coming to the another term, that is rigid body. So rigid body means a body considered as rigid when the change in distance between any two of its points is negligible. Alright. That means negligible means no deformation when the load is applied on the body. There is no deformation when the load is applied on the body. Now, here there are certain things are mentioned here while solving. Suppose the calculation of the tension in the cable, which supports the boom of the mobile crane under load, is essentially unaffected by the small internal deformations. So in the structural members of the boom, it's very simple. Suppose the crane is there, or if we consider it, the load is applied here, and the load is acting, some F1 is the force, it is acting on the body. So what happens here, the deformation or another part, it is the part of a body, link 1 and link 2. Okay, alright. The load is applied here, tensile load or compressive load. Suppose tensile load is applied on that in the direction. So the deformation in the part 1 or link 1 is negligible, no deformation. What is the meaning of that is that this link 1 is rigid body. It is the rigid. That means no deformation. That's what, with that assumption, we are going to do the static analysis. Next, if you want to find out the determination or external forces which act on the boom, we may treat it as a rigid body. So, if you want to find out the external forces, our assumption is the bodies are rigid. Okay. Next, statics. What is the statics it deals with? Once again, the statics deals primarily what? With the calculation of external forces which act on the rigid bodies which are in equilibrium. Okay, that's what statics deals with. Here, that is, statics deals primarily what? With the calculation of external forces acting on rigid bodies which are in equilibrium. Next, the determination. Another important is that the first definition, the definition of statics deals primarily, it represents what? Rigid body, the mechanics of rigid bodies. The next definition defines the mechanics of deformable bodies. What is that meaning here? Determination of internal deformation belongs to the study of, if you want to find out or calculate deformations, internal deformations, belongs to the category of mechanics of deformable bodies. Mechanics of deformable bodies, which normally follows the statics, the curriculum. Yeah, that is called mechanics of deformable bodies. So, the calculation of external forces, okay, and the reactions when the forces are acting on the body deals with what comes under the category of statics. That means what is the meaning? The mechanics of rigid bodies. And another one is that here, mechanics of deformable bodies. That means it is if you want to find out a determination of internal deformations, when you are going to study the internal deformations of your bodies, comes under the category of mechanics of deformable bodies. All right. Now, coming to some terminologies, very important terminology. What is the scalar and what is the vector? The scalar quantities are those quantities which are having only magnitude but no direction. Those quantities are known as scalar quantities. What are the examples of scalar quantities? By seeing the examples, we can understand better. Scalar quantities are time, very important, time, volume, density, speed, energy, and finally mass. These are the certain quantities are mentioned, comes under the category of scalar quantities. Alright, next, by understanding the vector quantities, we can understand what is scalar quantities. So the vector quantities, on the other hand, what are the vector quantities? Possesses what? Two things. One is magnitude and also direction. So, what are the vector examples for vector quantities are displacement, velocity, acceleration, and acceleration related what? Force, movement, and momentum, etc. These are the quantities comes under the category of vectors. These are vector quantities: displacement, velocity, acceleration, force, movement, and momentum. So, what about the speed? Speed is a scalar or vector? Speed is a scalar, but what is having? It is only having magnitude. Whereas velocity is a vector quantity. So that vector quantity velocity is what? Specified by two things: direction as well as the magnitude. The magnitude is the speed. All right. That's why speed is a scalar quantity. Speed is a scalar, and velocity is V for vector. Velocity is a vector. So these are very, very important. Why we have to study here? So we are going to study the characteristics of a force. This force is having not only direction and magnitude, it is also one more is that sense and also point of application where it is acting. There are four characteristics of a force. Number one, direction. Number two, magnitude. Number three, sense of rotation or sense of action. And finally, the point where it is acting. Alright, now here there are certain parameters, scalars and vectors. You can also study more and more. So the scalars and vectors, these vector quantities we'll study both in where statics and dynamics. Here the force, displacement, velocity and acceleration are to be studied in dynamics, force, moment and momentum. All these vector quantities are studied in the part of dynamics, and we are going to study, and also scalar quantity is a function of time, volume, vectors, but the force, external force are being studied. The way external force acts, this force, external force and internal forces are going to be studied in the part of statics. All right, so for these forces there are different types of forces are there. One is tensile force, another one is compressive force, and the third one is the shear force. So let us begin with, let us deeply study the vector quantity. Velocity is having both magnitude and direction. Here in this figure is represented by a line segment. In this line segment having the direction of a vector, and also the arrowhead is there, having arrowhead to indicate. What is the arrowhead indicates? The sense. This arrowhead indicates the sense. So here the direction, what is the direction? The direction is represents how much it what. And one more thing, it is also be measured. What is the angular measurement? The theta. What is the direction? And what is the magnitude? V having certain meter per second, suppose 20 meter per second. That means it's the magnitude. And also the direction. The direction is represented either upwards or downwards. What angle? That is the theta. So what is the magnitude of this vector? The length of the vector V, the length of the arrowhead, complete line segment, is known as the magnitude of the vector. So the length of the directed line segment represents and converts to some convenient scale. That represents what? The magnitude of the vector. Alright, that is the magnitude of the vector. Here we studied only about the velocity of the vector. Now suppose the same thing we are going to study the force. In this figures A, this is 10 lb is acting at point A. 10 lb is acting away from the point with the angle of 30 degrees. What is the magnitude? Let us begin with, the force is an action of one body on another. That is, the force is the action of one body on another. What is the one body? So the direction 10 lb is acting on another body, that is the point A. Alright, one body and another. If you blow one body and another, this is the force. Okay, if you blow like that, two forces, that is the collision, but two bodies, this is the force. One body acting on another is the force. This force gives what? Action. Action means the mass times acceleration. It has to come. This having mass means matter. The matter having certain acceleration, when it hits, that is called force. The force, that's why force is an action of a body, of one body and another. Next, your force, what is the purpose of this force? Your force, what is the action? This action, a force tends to move the body in the direction of its action. Alright, tends to move the body in the direction of its action. Suppose if you are posing like that, this direction, the force tends to move the body, this body, in the direction of the action. This is the direction of the action, it tends to move. Alright, that's why. And how can we know represents this action? The action of the force represented by or characterized by there are three things. You can see it here by its magnitude, and another one is the direction, and by its point of application. So in this figure, the magnitude of the force is denoted by newtons of the force or in newtons. The direction of the force is defined by the line of action or and the sense of the force. The line of action, this is the line of action, and the sense is upwards or downwards. And finally, by its point of application, where, on which point. And next one is the line of action is, what is the line of action? The line of action is an infinite straight line, along which the force acts, and it is characterized by angle it forms, with some fixed axis. So there are the different characterizations. So the action of the force is characterized by, once again, by its magnitude, another one by its direction, and finally the point of application. It is an important question for CAE examination, CAE 1. So describe the action, describe the force and its characteristics. The force is characterized by its action, the action of the force is characterized by, number one, magnitude, and number two, by the direction of its action, and finally by its point of application. These are the three characteristics of the action of a force. All right. So in this session, we have studied the terminologies of in engineering mechanics. First terminology we have studied the space, and second terminology is the time. Next terminology is the mass, how the mass affects gravitational force between the two bodies. And the next one we have studied the force, scalar quantities and vector quantities, and also what is the force, what is the particle. These are important terminologies we have studied, we covered in this session. All right, thank you.
Like, share and subscribe. Hit the bell icon for more updates.